Hi guys, welcome to my YouTube channel. In today's video, we are going to build a linear slider assembly from scratch, and we also can see how we can assign different mates and constraints so that we can push and pull the cylinder and see how it works in the real time. And I have also given many useful tips throughout the video, so do not skip the video and watch it completely. So let's go into the video. So first you can go to Festo website and you can choose actuators, pneumatic cylinders. In case you don't have a login, please create it, because these linear cylinder and other things, pneumatic items which Festo supplies, we can get the CAD data from the site directly. So I will choose a profile cylinder and which will be from a standard series. So I can choose DSBC. The star indicates the popular series. So if you have already predetermined the stroke of the cylinder, you can choose it here. So for now I will choose 150. So this basically filters and gives me the component that would suit 150 mm in stroke. Suppose for a longer length you may not have a smaller bore cylinder. That is why it's better you once filter it, check if that particular bore size is available, then you can go and configure the product. For this video, I'll go with 50 mm stroke. That is something that I have determined. Like, you can try with a different length as well. Now you can see we have configured all the necessity basic settings and the cylinder is displayed. You can click CAD or E-plan. You can accept the terms, and here we will go with 3D neutral format. And if you can see in that neutral format, you have all the drawings. We'll go to 3D neutral format and we'll choose step 214. Okay, so once you click that, you will get the data. So here you can see it is downloaded. Let me hit back, go to the zip and extract it. Now this file is extracted. Into SolidWorks, we can directly pull this and drop. So if you hover over the icon, you can directly drop it. You can also press Ctrl O and browse to this location and open this as well. So now see, you got the cylinder here in SolidWorks window. Here one thing we have to do before proceeding, first save it. It will ask you where to save, so you can define the location. So here I'm creating a folder stating slider assembly. So I'm saving it into this specific folder. So next, one important thing that you have to do is, if you click here, you will not be able to see open. The reason is that this is basically linked to the step file. So what advantage it gives us, in case if you're bringing in another step file, dropping into the same location, this would basically get updated. But practically for me, it hasn't been much useful. So we always break the link whenever we do a design. So now also what I've done is I've taken a section. You can see all the components here. So before proceeding into mating, you have to basically right click the component and make it floating, because right now it is fixed. You can see there is an F symbol displayed. So even if you mate, it's not going to move. So now I have removed the floating. So here the first mate, we have given coincidence, and the next we will give the distance. This is to basically indicate at what distance this particular nut is going to be from the edge of the piston rod. Right now I'll give 12. You can change it later when it's required. So now we have assembled the nut with the piston rod. Now again here you can make it floating and then start defining the mates. So I can clear this. First I have to decide which mate it is. So here it is important. We will go with an advanced mate. So what we are basically going to do is, we will define this particular edge and this one, and we will say the minimum and the maximum distance. Right now, if you see, I have choose a stroke of 50 mm. Yeah, I can see it here. So 50 mm I have chose. So now it is going to be from 0, that is the minimum, and maximum it's going to be 50 mm. So I have defined this, and now let's go ahead and define a concentric mate. So now this piston is completely aligned to the cylinder, and I have to check whether I've given lock rotation. Okay, so okay. This is to prevent the piston rod from rotating. See, if I pull it, it's not moving. I have to find what is the issue. Let's go and check the mate. So here there is 2 distance. I think this shouldn't be there. I'll delete it. I got what is the issue. So there is 1 distance. That distance is between the piston and the nut. So we'll leave this. I'll redefine the distance mate. So lock rotation I've given. I will go to advanced mate once again. Select the distance mate, not the distance one, advanced mate, and we'll choose this face, and this, let it be okay. So the maximum has to be 50 and the minimum has to be a lesser value. I think last time I gave 50 on both, so that is the issue. So now you can see it is moving between 1 mm and 50 mm. So it is clear now. So okay, so piston, now it's clear to move. So I'll go to mate on this. I think I just have to unhide it. It should be good. Unsuppress it. So now it's moving freely. So this is how we define a mate for a cylinder. The same thing you can do for any mechanism. It is bound to move between a specific mm. You can also define the width mate if you are very sure that the thickness of the piston shown here is perfect. Since we downloaded it from Festo, the width is perfect, so you can also define a width mate stating that it is free to move between the 2 ends. In case you didn't see the video that we have posted earlier on the advanced width mate, you can go ahead and have a look into it. So now let me change this to 20 mm and show you how this behaves. So now the piston minimum stroke is limited to 20 and 50. So I'll go ahead and change it back to the minimum value that is desired. So I can change it to 0 mm. So that could be the minimum and maximum could be 50. So rebuild it. To rebuild, the shortcut is Ctrl+B. And make sure to save the model often, because in case the system crashes or there is a power failure, and you are going to lose data. Now the next thing that I have to do is I have to go to the main screen. So I will allow it to reboot. Now the component is flexible within that particular sub-assembly. So here if you pull it, it's not going to move. So what we have to do is click here on the top. If you see, this float is different, and there is an option to make it flexible. So we have to make this top level assembly flexible so that the flexibility of the component is extended to the assembly above that. So now let's go into our main assembly. I will close this. First we have to save it and rename it as slider assembly. So another new component I will take. So this is gonna be the base plate on which the slider assembly is gonna be done. I'll choose a center point rectangle, define this. Let me exit the sketch and define the thickness. 10 mm is okay. I think I didn't define the dimension. So I'm going back, clicking smart dimension, defining the length and width of the base plate. So it's done. Now it's clear. So now our base plate is ready. You can click this to have the ISO view of the base plate. So I'm saving it. Let's define as base plate. Okay, done. SolidWorks accepts file name with space in between, but it is a good practice to have hyphen or underscore and not have space in the part name. Because this is going to be not going to be accepted in Creo and some other softwares as well. So now what I have to do is I have to download few more accessories for this part. So here you can see the accessories listed here, and this accessories you can also find from the drop down menu on the top. So this is one accessory I would need. So I'm just opening it in a new tab. So this is another accessory we might require, and there are two types of clever rod end. So I'll tell where to fix this. Okay, we might also require this sole flange. There should be multiple options. Okay, you can go here and you can find it. Download this. Yeah, here is the cylinder mounting. So we have to choose any of the cylinder mounting. You can check the catalog and find the use of each and every one of this mounting. But right now for this video I'll just directly choose it. So these are fittings that we don't need. We are not going to fit it right now. Okay, these are sensors. Okay, now I will download all the fittings and then we are in the SolidWorks window. So here is the piston. So I will rebuild it once and save it. Okay, so this is done. Now what I will do is I will go to the downloads and I have already extracted all the files. I'll just drag and drop all the step part that I have downloaded. We may not require all the fittings right now, but anyway, whatever I have downloaded, I will just drag and drop it into it, and let's decide which accessories we are going to use for this particular setup. So those are cylinder fittings, and this is a rod and fitting. Let me minimize this. Now what I also have to do is I have to break the link for the step which I have already indicated. So you can just right click and you can select break link. If you don't break link, it will be basically linked to the step file that you already had, and in case if you replace the file, you will be able to automatically update the features. Now we don't want it, so I've braked the link and I'm opening each component and I'm saving it in our working directory. That is where we are saving the other assemblies and parts for this particular video tutorial. So this is the location. I'm going to copy it, save. So this clips I have saved it in this working directory. Next I will choose the next one. I'll save this also. So by default, when you save it, it would probably suggest you the location that you have opened the file from. So make sure you are saving it in the respective place that you wanted to save it. So of course, SolidWorks is going to take the link from wherever it is earlier referenced. But if you're working with if you're working with Creo especially, you will have issues on this. So this is what I'm going to fit, and to rotate the component you can just right click it and hold the right mouse button and move it so that the component will be rotated. So now I am going to assemble this with the cylinder. So I'll choose concentric. So this bolt I'll make concentric with this particular mounting place, and this again I'll make it concentric with the other bolt. So now the position is defined. Now the height is also defined. So that is done. Now I'll try to mount this. See, we have a problem here. So in the slider assembly I have shown you, basically I had the cylinder horizontal to the mounting plate. But in this issue, in this case, if you are trying to mount this particular clevis, what would happen is it will hinder with the other clevis. So I'll delete this. I will make a separate bracket for mounting it. There is also a supporting clevis for this particular orientation. You can check the catalog and you can download it from Festa website and try it. So for this video I will make a manufactured support bracket and I will assemble it. Now let's assemble this rod end. So rod end, it's going to be fixed here, and I'm going to lock the rotation. So practically how they will lock this rod end and the cylinder nut is, they will screw this rod end to the cylinder and then they will torque the nut against it so that it is locked and it won't move. Okay, so that is how they lock it practically. So there should be always some space between the nut and the end of the rod. So now I'm trying to pull it, it's not moving because I didn't define the flexibility. So I have now made it flexible. So now you can see I can push and pull the cylinder with the rod. Okay, that is clear. Now let's move back to the main assembly. So here is the bracket that I have designed. I didn't show how we are designing it right now because of the length of the video. So it's simple bracket you can design. First just design it, and then dimensions you can modify according to the assembly. You can bring it here, assemble, and then so here I'm going to use the advanced mate. So I'm using with mate, you can see. So it is aligned at the center of the component. What are the other thing you can also do is you can select the center plane of this component and the center plane of the base plate, and you can do it. And one more important trick, when you bring it you can just reorient it with that specific tool which is shown on the left. So I'm assembling the cylinder here. I'm not going to lock the rotation. Then again I'm going to give the advanced mate because I want the cylinder to be right in the center in between these two support legs. So that is done. And now I have the assembly. I will collapse it. And what I will do is I will try to check if the cylinder works. Oh, it's not working. So what I have to do it, I have to make it flexible. So you can see the make flexible assembly here. There is one more way. In case this is not shown, you have to go to this custom property and here you have to click flexible. Mostly that shortcut icon can be used. In case if it's not displayed for some reason, then you can use this, because sometimes if you have some errors that may not be displayed. So this is done. So now this component is flexible. So I'll collapse the tree, and here you can see. So I'll make a new part. This is basically for the slider. What we have to do is we have to do something known as a dip plate. So we'll have two C type plates on the sides, and on the center we will have some plate to slide. So instead of this dip and plate setup, you can also have a linear moving rails, we call LM rails, or some bearing setup. So that will let the component only move one particular axis, let's say x-axis. So now I'm defining the gib here. You can define, unless if you don't know the exact dimensions, you can just make it a round dimension, and then you can edit it in the assembly as per your requirement. So there are two dimensions which we should note. One is this extension, that is 20 mm, and the height, which is 20 mm, that because that is the thickness of the plate that we are going to do. So instead of blind, I'm using mid plane option, so that I will have the plane at the center. Let's make it 100 mm. We'll see how much length is required when we put this in assembly. It's not that you should know all the dimensions at the first hand. You can the biggest advantage with 3D modeling software is you can define some shape and then go and edit it in the assembly. So that is how designers also do in real time. I have been almost working with this softwares for almost 8 years now. So practically that is how we do in real-time engineering, because we may not always have an understanding on how much will be the dimension. So this is the next part, that is a slider I'm trying to design. So I have defined a center plane and I am mirroring it so that it would be symmetric. Okay, I think I have given cancel, so I'll re-mirror it. Okay, so this is done. Now I will simply connect this and connect the base. You can see most of the dimensions, most of the lines here are blue because it is underdefined. So as I keep defining the dimensions, you can see the lines turning into black, which indicates that it is defined. I have given the dimension, so you can see certain things would become black color. So this color also you can edit in case if you want. This is the default color. So underdefined are shown in blue, and the defined entities are shown in black color. So now this is blue. I don't know. Okay, this is the reason. As you can see, it is not coincident with the center. So if I give the basically midpoint, so now it is coincident. So only that is blue because the height is not defined. So this way, if there is an under constraint component, you can check and define. So now all the entities are in black. That means everything is defined. So we shouldn't. It's not. We shouldn't. It is not a good idea to have a component underdefined, because when you define a dimension, when you change a dimension, it may not behave the way that you wanted it to be unless you define all the other parameters. So if you have defined all the parameters, so whichever dimension you want to edit, that particular dimension alone you can edit, and the component can be expected to behave the way that you want it. So now I'm bringing in the gib plate. Okay, so gib plate 1 is here. Then I have to bring in another gib plate also. So you can directly bring it from here, and also from the feature tree you can copy and paste it. Basically, as Control C and Control V, if you do, I will be able to copy and paste it. So these two gib plates are going to be on the sides, and this is going to be at the center. Okay, done. What you can also do is, for your reference, you can go to the first part of the screen and take a snip of the complete assembly, so that in case you are following this video and doing at the same time, it's okay. If you want to see this video completely and then you want to try, and if you have a doubt, for reference you can directly just refer that image. Okay, so now I'm going to center this component about the cylinder. Okay, done. So this is centered. Now this gib plates I have to define. to make this with the cylinder, I think I probably need a hole, which I will do it. So right now, since we are into the assembly, we will make the other components. So to this phase, it has to be coincident. So this is fixed. So now I think it can move on other two axes. So I have to define the other two axes. So for this particular axis, that is Z axis, I'm just saying that this part and this part has to be coincident, because we have already defined this Z axis for the middle rocker. So this is defined. Now only X axis has to be defined. So in this case, I think it's better to take the reference from the mounting, because length of the cylinder, in case if you change it also, this is going to remain same, and the cylinder is going to move dynamically. So you shouldn't take reference from the moving component. This is done. Now the second part, I can basically define this coincidence with the plate and this dimension with this other gib, because we already defined the dimension. So that what would happen is, when you edit one dimension, the other related part also will move accordingly. If you again edit this particular component with the fixed reference, whenever you want to change it, you basically have to change it at two different places. Now we can see there has to be a hole here. So I have seen the diameter, so I'll open it. So I have to create a simple hole. You can do it using the hole wizard and extrude command also. Generally they teach you to go with extrude command for simple holes, but why we as engineers don't prefer that is, if you create a hole using hole wizard in your drawing, what you can basically do is you can do something known as a hole callout. So this is a very important feature that you have to use, because when you use a hole callout, if you change, let's say M6 tab to M5, and if you go to the drawing and rebuild it, it's gonna get updated automatically. Whereas if you do it on a cut to extrude, the diameter will get updated, but of course the depth and other things, what you are going to do is you are going to manually define it, like through all and all those things. Text you have to put it manually. Whereas if you do it on a call out, it would basically define. If it is a blind hole, it will give you the symbol and say 5 mm or 10 mm, and if it's a through hole, it will say through all. So when you update the model, that would be updated automatically. That is the thing. So now you can see I have assembled this center slide plate also. So when I pull it back, it is basically going beyond the gib plates. On the front, I have some space. So what I will do, I will edit this. So I can go and view mates and edit. Also, I can double click and check. Okay, so if I double click, the component dimensions can be edited, and this arrow cannot be pulled because you have completely defined it. I'll give view mates. So here is the distance. I'll edit it to -30. Okay. Now to close this, I'll rebuild it. Okay, this has moved. So now it's clear. Okay, the other side, it's protruding outside. So for this, what I have to do is I have to basically increase the length of the gib plate. So I have measured the dimension. Double click it. Instead of 100, you can make the enter the new dimension. So now it is done. So this rocker assembly is done. So this is how you edit it in assembly, guys. Don't it's not necessary that you have to know the complete dimension each time. So you can, if you know the shape, just bring it in and then you can modify it. Because as a designer, when you just bring in a component and try to do something, then you'll understand, okay, this may not going to work out. And in that case, defining the complete dimensions and the parts is basically going to be not going to be useful. So this is done. So now the final part, I can basically drill in at a couple of holes, and then I can define the screws for this. So that is the missing part. So here I will go with the counter bore hole because the height of the block is high. So if you have a counter bore, you can have a smaller screw. That would be preferred. So I will go with the counter bore. So we'll have 3. So 1 toward the middle and the other one at the other end. Okay, what I can do is I can make it symmetric. So I'll make this constant and create a mirror of this entity. You can also place the hole and then you can give symmetric. Now you can see this is moving, so this has to be constrained. The ideal thing would be to first define the center line and then do it. So that in that case it would be really easy. So this hole and this hole has to be made vertical so that all the 3 are in line. So I can define just 2 dimension from this edge, how much it's gonna be. Okay, I'll have it as 12. Maybe 8, yeah, that should work out. Now this overall length also I'll define it. So 90, can make it little bigger, 100, okay. So okay, 3 holes are defined, so it's reflected on the other side as well because it's basically the same part. So this hole, whether it's in place, how we are going to see is you can go to that particular view and you have to go to this particular icon, drop down and click the wireframe and see it's not interfering with any other components, so it's good. So right now it is completely defined. And this is the assembly. Now I will try to drill few more holes on this support bracket also. So I can edit the feature part and I can go to that part feature, create a simple hole. Here I don't think we need a counter bore hole because the thickness of the component is already less. So I'll go with the same M6. And there is also one more thing, whenever you define an assembly you should probably try to have the same fastness as much as possible, because practically during maintenance what the engineer would do is he would probably carry a single like 2 or 3 Allen keys, so maybe M6, M8, M10, and for a bigger assemblies you might carry M12 as well. So even for some places it may not be the actual requirement to have a bigger fastener, but for the sake of having a similarity in the design we would generally prefer to have the same thread. Like as I said, like for the rocker assembly in the front you may not need M6 because it's not going to get affected by the load basically, so you can go with the M4 also, but we would prefer and stick with M6 because on the mounting side you will definitely need M6. So now this hole is defined. Now on the base plate to define this hole, simply edit this part. We'll try to use the reference of the hole which is already on the top. That would be the ideal thing. So the other two was screw clearance. Now this is going to be a tapped hole. Like M6, I'll go to the position and here you can see it's very simple. If I already defined a hole, simple, you can directly coincide with the center of the mating hole. So this is one important feature and the greatest advantage it gives us. In case you are moving the bracket, these holes are also going to be shifted automatically. And if you have a call out and when you rebuild and shift to the drawing, the position, everything is going to be updated automatically. So let me save it. As you can see, all the tab holes are created already. Now this is the assembly, and see, I didn't edit the depth of the counter bore. It should be more. It's better it's more, because then you can have a shorter length bolt. Okay, I think this would be better. So there are two purposes for using a counter bore. One is to make sure the head of the bolt is below the surface, and second thing is, in such cases where you want the length of the bolt to be shorter, you can use that. Now you can see I have already selected the socket cap screw, so you can directly drag this and drop it. Okay, sorry. So I can drag and I can place it just above this hole, and it gets mated automatically. And you can see it is recommending M6 because the hole size is M6. It can identify it. So only the depth, that is the length of the component, I have to define. So if I define 25, it's basically projecting outside. So I'll make it 20. Practically, what we do is, generally for bolt, the thread should be 2 times of the size. That is, if it is M6, the thread length we basically define minimum. We define it as 12, and the minimum engagement for the bolt on the hole should be 1.5 times. So it's 6 plus 3. So minimum 12 mm. The bolt should be engaged on the thread. That is what we define. For these cases, what you can also do is, you can make sure it is not protruding outside. So why I am dragging another bolt is, here length could be different. The length on the other bolt could be different. So I am going to choose a different length for this. So it's going to be, see here, it's still not reached the end. Okay, I think I can have a little more length as well. Since it's a through hole, I can directly have a longer length bolt. And you also have to define a washer. In this example, I didn't do, but it's good to practice to have a washer and a bolt. Now I'll go with the pattern. So the pattern should be pattern driven component pattern. Okay, yeah. So what it defines is, you can pattern an item based on some feature. So on the base plate, I'll try to choose the thread that we did. Here I can have visibility. Okay, I have choose this. Okay, now if I choose that thread, the problem is it's getting projected here as well. So I'll edit it. Okay, so I can remove. There are two options. So you can just remove the seat position at the instance. Maybe what other thing I can do is, this is one option. So you can select the start position. So now if I click this as the start position, you can see it is shifted to the other end. So basically what I've done right now is, I have defined the first hole. Let's be it in place. So instead of this feature, I'll see if I can define the counter bore. Now if you define a counter bore, let's see what happens. Okay, so the bolt is only fitted on one side. So this is not what we desire. So I can basically use this feature, that is skip the driving feature. Okay, so there are two options here. I'll delete this, as I'm doing just to show you the different options. So I have choose the base feature, and here I can skip the references that I don't want. So now all these 4 are going to be skipped. So whatever whatever bolt we have defined here, it's there. and for the other bolts in the grip plate we have basically used a pattern. Now let me save it. I will group all this fasteners into a folder. Right click, you can go down. This is when you are not going to use fix, you are going to use add folder, and here you can give a name, maybe fasteners or screw, whichever you prefer. And you can also define based on assembly, like mounting screws or mounting screws, grip screws, and all those things. So now that's it, guys. We have done all this, and here there has to be one more pin which I'm not showing it here, but if you want you can also try it. Now I'm able to slide this, and practically this is how it's gonna work. And that's it, guys, for this video. Thank you for staying tuned, and I hope this video would have been really helpful for you. Do subscribe to our channel and give a like if you have learned something, and do comment if you need some more information on any part that is defined or explained in this video. That would help us redefine our videos and make better contents in the upcoming days. And I would also recommend you to see our playlist where we have defined many tips and tricks in SolidWorks, and also there is a separate playlist on macros that we use in SolidWorks. Macros can be a great way to improve your design efficiency, and that is also a good way to automate things. So it's very simple. I've defined the basic things and I've gone through step by step on each program. You can have a look at it, and thanks for staying tuned. And if you are a new viewer to this channel, please subscribe to our channel. That would support us, and we will be posting a lot of videos on tips and tricks on not only SolidWorks, many design softwares. Once again, thank you, guys. Let's see you in the next video.